This video briefly discusses some key facts you must know about angles contained within shapes that are drawn within circles, and these can be known as circle theorems. Now then, suppose you've got a triangle which is formed by a diameter passing through the centre of the circle. Then the angle at the circumference is always a right angle, i.e. 90 degrees. So we can therefore find a missing angle because the angles add up to 180. So 180, take away 90, take away 32, gives us 58 degrees. So we can find out missing angles contained within circles by knowing key properties. So a second one, suppose you've got an angle at the centre and one at the circumference. Then the angle at the centre is always double the angle at the circumference. So this angle here is quite simply 2 lots of 30, i.e. 60 degrees. And that fact will always hold. We could therefore find the angle here, the reflex angle, because angles at a point add to 360, so that big angle there, for example, would be 300 degrees. So the angle formed at the centre is twice the angle formed at the circumference. Again, quite simple rules. The third one involves what's called a cyclic quadrilateral. There we go. Now this states that opposite angles in a cyclic quadrilateral, i.e. a 4-sided shape where the vertices touch the circumference, these angles add up to 180 when they're opposite. So that angle there and the one opposite add to 180. So that must be 72 degrees. Similarly, these angles will also add up to 180. So therefore that must be 116 degrees. And then the final one on this page, one which is obvious but often missed, is that because these two lengths here are both radii of the circle, they must be the same length. If they're the same length, this is an isosceles triangle. So therefore these two angles are the same. So to work those two out, if I do 180, take 70 as 110, and then halve, these two angles here must both be 55 degrees.